Okay, welcome to Beginners Python and Machine Learning, meetup number 66. Today we're going to be looking at how to create PDFs in your Python scripts. So Beginners Python and Machine Learning, we try to teach you Python by giving you exercises that you can follow along and do at the same time. On the first week of every month, we have an absolute beginners, so that's really good for people who've never done any programming before and never seen Python before. And then on the other weeks, we look at a few different topics. So next week will be absolute beginners. 2 weeks after that, we'll be doing machine learning. If you want to chat along, you can put chat comments in the YouTube chat or in Slack. And the links for getting onto Slack are in the description on the meetup. Here we go here, skypyproject@gmail.com. And those same comments should be on the YouTube site as well. For today's session, we will require you to have Python installed on your computer. And we've provided a few, as well as doing that, we recommend an IDE such as PyCharm Community Edition. And then I've provided some source code for today, and we'll also need the source code from last week, so I've provided a link to that here as well. So I'll show you how to get set up. First thing we want to do is download the source code. So this will take you to here, and I'll just do save, which is Command S or Control S, and we'll save this into a new folder in PyCharm projects, which we will call Beginners Python and Machine Learning Email PDF. Doesn't matter what you call it, but that's what we'll be calling this one. Now the instructions for this setup are in this file. This one's here, meetup 66. Tim, that's me, and PDF is what we're learning. So if you see here, task 1 is how to set it up. You make your directory, change into directory, and you want to put these files into there. So let's grab the other file as well. So I'll save that into that same directory. So most of you have got this all set up from last week, so you should be just able to sit back and relax at this stage. And now we'll run PyCharm and open up that project that we've created. Now when the project starts up, we've got an error down here in the bottom right. It says no interpreter, so we'll just better set that up. So I'll go PyCharm Preferences. On Windows, that'll be Settings, probably in the File menu. And we go down to here, Project. Now I'll just whiz through this. If you've got any problems, ask any questions in the chat, and I'll go through it a bit more slowly. Okay. All right. Looking for an interpreter, so show all. There's a couple I've been using before. Let's create a new one. So I'm going to create a new environment. I'm using Python, so I'll be a virtual env environment. If you're using Anaconda, use a Conda environment, but don't use either of those two. And we'll call it our virtual environment in Beginners Python and Machine Learning Email PDF. I'm basing mine on Python 3.8, which I've installed through Mac ports, so that's why it's got this path. It'll be a different path if you've installed it some other way. Now the reason you want to create a PDF in Python script is if you're trying to automate document creation, so you might have a Python program that runs along for a long time and at the end it has to create a report, and you want it in a format that is easily attached to emails or printed out with formatting, and so PDF is good for that. You might also be generating documents like invoices or receipts in your Python script, and so PDFs are good for that as well. Okay. Let's just, I think I used the same path as one that was already there, so we'll create it again. Oh, it's not, okay, so there it is. We'll use that. Yes, there it is. Okay, so by default the virtual environment comes with just a couple of things installed, and so we're going to need to install some more things. So the way we do that is we create a file called requirement.txt. So I've just right-clicked on the folder, that's our project folder there, and said new file, and the name of the file will be requirements.txt. Now that's currently empty, but if we look at the code for Meetup 66, we'll see that in the instructions I've given you some things to put into this requirements.txt file. It's all the same as last week, except we've got one more, ReportLab. Now ReportLab is the software that creates PDFs. There's a few different third-party libraries that do PDFs. So from what I've heard, ReportLab is one of the more tricky ones to use, but it's also one of the most powerful ones in what you can do with it. So I thought, let's start with that one. Now that we've put those third-party modules, the first four are all required for email, and the last one is required for PDFs. We can install those requirements, and if you're doing this some other way, the instructions are at the top of the file. So that'll go away and install in the background. And meanwhile, let's have a look at some of the links I've provided. So this first link here is essential. That's your that's the user guide for ReportLab, and you'll be referring to that quite a lot, and it comes as a PDF, so that's good. You can just keep a local copy. So I've downloaded it. That's what it looks like, and all the way through today's session I've put references to different sections in here, so you can find out more information as we're going through. And you can see there's quite a lot required to create PDFs. The source code is at this URL, and the HG means Mercury, and they've stored it in a Mercurial source code repository, which is a bit like Git. In fact, it's, I think Git was modeled on Mercurial, and now everyone uses Git, but apparently ReportLab still use Mercurial. So if you go to that link, and I'll hold down the command key and go to that link, then you can see the files, and you maybe just grab the zip file there, and you can download that and unzip the files. And that's useful. It's got some demos in there, so if you have a look at here, I've downloaded it into Documents, ReportLab, and here's some demos of different things. So we'll talk about them later. For example, in fact, we'll grab this demo while we're here. So I'll just open another. So odyssey.py shows how to convert the a text file which has got the full story, Homer's Odyssey, in it, and how to convert that to a PDF. I'll move that to there, and I'll just get that off the screen. And I've actually, the source code for Homer's Odyssey is in this file here, so I can download that. There you go, that's opened it up, and I'll save it in the same file. Now, yeah, for it to work in this demo, you have to call it odyssey.full.py. requirementstxt. Okay. So just having those in the directory, we can run this demo. Command Shift R. Control Shift R on Mac, and I think on Windows it's Control Shift F10. All right, so in 0.23 seconds, it's done 281 pages, which compares well with the 3.76 seconds or 10.83 seconds that it took when this demo was originally written several years ago. Okay, so if we want to install ReportLab just from the command line, you can, if you're using Anaconda, I'd suggest you first type so you've activated it here, Conda activate, and then you want to Conda install, and you have to give it a -- name the virtual environment that you want to install, and you can do -- file requirementstxt, or you could just put in ReportLab, so that would be Conda install like that. Because you should have all the other ones already from last week. This is for Annie. But if you want to just add ReportLab, you can just install it like that. If you're using pip, then it's just a case of pip. So this is for people who don't have Anaconda. Pip install ReportLab. Okay, is this in my Python console in Spider? So no, it's not Python console, it's in terminal. So you have to either run the command line. So if you've got Anaconda installed, you'll have a Anaconda command prompt that you can bring up. And from that, you can install you can activate, well, you have to, if you haven't created it, you create your virtual environment by typing that in Anaconda, then you activate it by typing that, and then you can install by this. But the install is going to have problems with Google code. I think we found last week that you had to actually use pip after you've activated the environment. With Anaconda, you should always try Conda first. If that doesn't work, then you try pip. So I would probably, if you're using the same one, just use Conda install -- name venv email pdf, and then put the name, which is ReportLab, that you want to install, the name of the third-party library you want to install. So let me know how you go with that. I'll just type the Anaconda one, and I'll leave it on the screen while you're no -- As Anaconda puts all its virtual environments in a particular folder, so every time you work on them, you have to give the name of the one so it doesn't get confused with the others. While with the pip virtual environments, you can put it in the same folder as I have here, so you can see there's my virtual environment venv. It's there, but you should never go into it. Like if you look into it, you'll see all this stuff, but don't go in there, don't add files to it. Just leave it for pip to manage, and don't make any changes there. All right, so while we're doing that, okay, so we've just run odyssey.py And you can see in our directory we've now got another folder called odyssey.pdf. And if I look at that, that was the one that was created in about a quarter of a second. And you can see it's taken all the text from the text file and it's put it into this PDF. And it's also put a title on the top of each page and drawn this line here. And at the bottom of each page it's drawn another line and it's put a page number. And so those are the sort of things you can look in that demo to see how to do. And after today's session, you'll be able to do even more fancy formatting than that. Right, so let's go through the basic concepts. We're going to go through, I'll just introduce you to what's in section 2.1 of the ReportLab user guide. We need to create what's called a canvas, and then we need to draw on that canvas, and then we save the canvas. And then when the canvas gets saved, it creates a file with the file name that you gave it here, and then that will be your PDF. So we'll call our function. So canvas, you see here, that comes from the ReportLab PDF gen.canvas library. So that's the class. And A4 is just a convenience set of size for page sizes. And in fact, for Canvas, the default is A4 because this code was written in England. And if you want other sizes, you need to specify them in page size. But I've specified it here, even though that's the default. And then we can run it. So we can run it. I've been playing around with Unicode, so I've said my first 2/5 of a PDF. But we'll see how that works. So we ran that. It's created a PDF file. It's a very blank, just a blank piece of paper with these words. My first square PDF, so I didn't know how to draw the 2/5 glyph. And it's put this down below halfway on the left-hand side of the page. So that's created a PDF. What more do you need to know? You can just put any text at any XY position on the page and you've got your PDF. So since it's so close to, I'll just bring that terminal thing back for Annie. Since it's so close to last week and we were sending emails, let's try to send that PDF that we just created as an attachment to our email. So for people who are just didn't come to last week's session, then you'll need to open up Meetup 65 and go down to here, and there'll be an email to, and that's where you put in your own email address. I'll put in my one, pythonatordev@gmail.com, and save that. So we're now, from this code, we're going to import the methods from last week's code, and you can see that in our import commands over here, which is not imported there. Import. Oh yeah, here, this import command here. Normally you put all your imports at the top, but I've spaced them through so they're close to the task that uses them. So from Meetup 65 Tim email, which is the file here without the .py on the end, import send message via Gmail and message from string. So this message with PDF file attachment, it's almost identical to our code last week, which was a message with image attachment. we send the file name, it opens the file name for read-only as a binary file, and it gets all the bytes out of the file, puts them into PDF data, and then it adds that attachment to the email message that got created by calling message from string, also from last week. And this time the main type is application and the subtype is PDF, so that'll create a MIME type of application/PDF, and we've given it a file name PDF report.pdf. So let's try running that and see what happens. Oh, okay, yep. No such file or directory credentials.json. And yes, so for people who, I'm not going to go through creation of that again. We did that last week. So I'm going to copy those files from last week. But if you want to create that, then watch last week's video. So last week we had this file here. I'll grab a copy of that and this file. And now if I run it. Okay, so it says process finished with exit code 0. So in Python that means everything worked without problems and the email should have been sent. So if I look at the email, let's have a look. At my inbox, I see the email that came through, and if I can look at that email now, and it says my first black square PDF. So I've successfully created a PDF and sent it as an email attachment. So I'll just delete that. Now you may have noticed all these errors here. Module not found, file cache is unavailable when using OAuth 2 client. It's a known bug in the Google code that it produces all these warning messages. So to get rid of those, even though it all worked, we can go to that method, and in fact I like doing it from here. So we've got send message via Gmail. If I do Command B on Mac, and there's a similar one on Windows, I can't remember what it is, that takes us to calling this method here, which calls Gmail service. So let's Command B on that. And here's Gmail service. And in Gmail service, that calls build. And if I add an extra parameter to build, cache discovery equals false. Then it says don't bother looking for a file cache, and that should get rid of those error messages. So let's try that again. I run that and we get no error messages. So I'd be interested to know if anyone at home's trying this, if they got those warning messages and they have to add that cache discovery as well, but I certainly did for the PDFs, but for some reason I didn't need to do it for the images. Okay, so Annie's saying she got ReportLab installed successfully, but she's getting a module not found, no module named ReportLab. So if you're in Terminal and you want to see what's installed in your current virtual environment, we can see ReportLab is here, and you can see the virtual environment is active because it's got the virtual environment name in brackets at the start of the command prompt. And there it is installed with all its dependencies. So if you're saying Spider is not using it, then Spider may not have that virtual environment active, and I don't know Spider well enough to know what needs to be done to do that. But if you can somehow select a virtual environment for Spider, then that might fix it if you're actually seeing that ReportLab is properly installed in that virtual environment. So do we see the email go through? Yep, there it is, and that was with no error messages this time. So it's got the PDF report down here, 1.5 kilobytes. So I can happy with that, so I'll delete it. So now I'll just disable this message, this command, so that we don't send an email every time we run this file. So to send that file as an attachment, we had to save the file onto the file system and then read the file off the file system back into the computer to be sent. So sometimes we don't want to save it at all. We just want it in memory for a short period of time, send it as an email and never save to the file system, so we don't clutter up our file system with all these files. So we use the Python IO library for that, and the Python IO has got ways of creating these in-memory files. So we can do a bytes IO or a string IO, and string IO is for strings, and if you're wanting to replicate a text file, but we're wanting to replicate a binary file, so we'll use bytes IO. And let's just open this link so you can see what it talks about. So IO on docs.python.org talks about text IO, which is the same as opening a file here with just R for reading, and you can do the same with string IO here. Binary IO is the equivalent of if you've got a B in the file, then you would use io.bytes.io. And raw IO is unbuffered, so we won't bother with that. Okay, so you can read all about it there, but let's just try it with some examples and see how it works. So we create a PDF buffer. So a buffer is just a place in memory that collects this data. And then we can pass that buffer straight to the canvas creation that we're doing with ReportLab, and it will save all the data straight into that buffer rather than putting it into a file when the save command is issued. So this buffer is just a selection of memory. And then to get the data out of memory, we do pdf buffer.getValue, and we have to do that before the buffer is closed. So we do that, we store that into our variable called report, and then we close the buffer. Now, because we've used this all in a with statement, that will automatically close the buffer. So I don't need to do pdf buffer.close. It'll do it automatically, and it'll clear all the memory used by the buffer. So using with statements is a really good way of making sure you don't have memory leaks and use too much resources. Then that report can get returned, so that'll be the PDF report is getting returned, and it can be used as a PDF buffer value. So we can send that message via email. We call a message with PDF attachment, which is this. We create the email message, we add the attachment using PDF buffer value, just the same way as we used the data that we read out of the file. And then we can, all the other parameters are the same, and we can send the report. So this one's called PDF report from memory. Let's just see if that worked. There we go, that says it got sent. So I'll comment it out for next time. And look at our inbox, and attaching a PDF document from memory to an email. So this one, the PDF got created in memory, never saw it to the disk, and got attached to an email and sent. So feel free to ask any questions as we're going along. Also, if anyone knows about Spider and how to activate or select the correct virtual environment, if they could just place it on the chat in our Slack channel, Beginners Python Learning to Code, or even on the YouTube chat. All right, so let's go now onto more detail about how to create these PDFs. So we've seen that we can do a drawstring command on a canvas, and that will put the text at that location on the canvas. Now the units that we use for X and Y, they're in values called points. And our point is a 1/72nd of an inch, and it's the same point that you use for font sizes. So 12-point font is 12/72 of an inch in size. But sometimes points are a bit hard to work with. I prefer to work with millimeters, and so ReportLab provides some convenience methods here. They're not methods really; they're just constants, millimeters. So this is a constant that converts between millimeters and points, and it's quite easy to use. You'll see if I import millimeters, all it is just a float that's 2.83. It's basically saying there are 2.83 points in a millimeter. So if I want to know how long 34 millimeters is, it's 96 point. And it's just multiplying two numbers together. There's nothing more magic than that. But it makes it easier when you're specifying X and Y coordinates. You can just say 34 times mm, and you know that coordinate's at 34 millimeters rather than at 96 point, which I don't have a good feel for. So task 7, this is a task I suggest you have a go at yourself. I've provided a solution here, but my solution's way too complicated. So you can look at the solution that I've provided and see if you can come up with a simpler solution to the problem. So what I've done, I've created the canvas, and then I've gone for lots of different points. Oh yeah, so what we're trying to do is we're trying to work out what the coordinate system is that ReportLab is using, well, in fact, what PDFs are using. So we need to know where the origin is on the page, and we need to know how big the page is and which way X goes for increasing and which way Y goes for increasing. So I've got PTX, which is my X variable in points, and I've also got MMX for my X variable in millimeters, PDY for Y in points, MMY for Y in millimeters, going up to the size of an A4 page. And you see A4 is just two numbers, so I can just refer to the first one as A40, which is the width, and A41 is the height. When I'm doing millimeters, those numbers are in points, so I have to divide by mm to convert back to millimeters. And I'm going to go up in 50s and up in 2 inches, so about 2 inches each time, and let's have a look at what it looks like. So let's run my code and see what it looks like. PDF demo 7, and then we'll try to create a simpler one that does a similar thing. Here we go. Hopefully if you run it you get a similar looking thing. I've got page 1, I've got page 2. On page 1 I've got all these coordinates. I can see that 0, 0 is down in the bottom left. 144 point, that's 2 inches, then 4 inches, 6 inches, 8 and a bit inches, so 432 point, and you can see it goes up. So X goes up across the page, Y goes up going up the page, which is different for most coordinate systems. on computers you start 0, 0 here and then x goes up this way and y goes up this way. But in this one we're doing it more like the mathematical coordinate system, so lower left corner is 0, 0 origin. And similarly in millimeters, and we know that an A4 page is 210 millimeters across and 297 millimeters high, and this seems to agree with the numbers that we've got here. And the other useful thing to notice here, I've drawn little crosses on these coordinates, so the text is actually starting, and the lower left corner of the text starts at those coordinates. So that's a good thing to know as well. All right, so let's try to do the same task but a bit simpler. Task 7, going to a file. Remember that file can be a file buffer, a PDF buffer which is in memory, or it can be an actual file saved on the file system. So we need to create our canvas with the file, and that can be a file name or a file buffer. And I won't put a file size in this time. And then we're going to draw a string, and the x coordinates I think we'll do it at 100 millimeters, and y is going to be 300 millimeters, and the text is going to be just 100 millimeters, 300 millimeters. Draw a string, and we'll do one further over to the right, so maybe about I might make this a bit more to the left, so we'll go 30 millimeters, and that's 30 centimeters. Yeah, I don't want that much. $100 millimeters and 250 millimeters. And the only other thing I need to do is save it. Okay, and then call it. Run that. Let's have a look at what we got. So 100 millimeters is down here, so that's 30 millimeters across and 100 millimeters up. And this is 100 millimeters, 250, so it's 100 millimeters across and 250 millimeters from the bottom of the page up to there. So that gives us really all we need to know, that the origin's down in the bottom left-hand corner. Okay, I can turn them off so that we don't waste time creating these every time. Now, one thing you would have noticed in our demo 7 was that there was a 2 pages. Now, the way to go from page 1 to page 2 is to use show page. So when you finish drawing on one page, you say show page, and that ends off that page and prepares the new page if one is required, and then you can write to that one, and then after the last page you don't need to do show page again. You can just do c.save, and that will save it for you. You also would have noticed that we did some drawing operations, so we were drawing lines, and the lines, you just have a line goes from an x1 y1 to an x2 y2. You can set the color of the line, so there's a command here, set stroke color RGB, and that just gives you the red, green and blue components of the color that you want. And this time we're going to introduce a new type of string rather than draw a string which draws it with the left part of the string hard up against the coordinates. we're drawing a centered string. So the center of the string will be on the coordinates, and I'll draw this cross on these coordinates, 105, 10, to see what exactly part of the string is centered on that cross. So once again, look up the reference manual to see all the different things you can do with drawing strings, centered strings, drawing lines, where you can change the thickness of the lines, the color of the lines. There's a lot of stuff that you can set, and that's what gives us its power. Let's run that. Now we've got PDF demo 8. And let's put page 1 at the center at the bottom. Page 2 is at the center at the bottom as well. And you'll notice there's the cross we did in a slightly greeny color. And that shows that the center, when you draw a centered string, is the baseline of the text is centered on the coordinates that you provide. So most of the text goes above with just the descenders going below. Now we also tried to draw a string that was a really long string, and you see what happened? It just ran off the page. So draw string doesn't do any sort of word wrapping or anything, so it's a little bit inconvenient. So every time we want to put text on a page, we've got to specify an X and a Y, and we've got to work out, is it too long for the page? If we wanted to put another line down, we'd have to do another X and Y. We'd have to calculate the X and Y of where the new line is going to start every time we're drawing a new line. So, okay, and that was going to be on for task 10, but we've still got task 9 to go, so let's have a look at this one. What was the point of task 10? Show page. Okay, actually we'll do this. What's the minimum task we can do that will create a 2-page document? So let's give that a go. This should be fairly easy. We create our canvas. We draw something. Let's just, we'll do a draw string. And we'll put it up in the top left. So where would top left be? It'll be 30 millimeters times millimeters and to 70 millimeters. Page 1. And then the important thing is to do the show page to give us the new page, and then we can draw a string, same place. Page 2, and save that. Let's have a look at that. Page 1, page 2. It's a very simple 2-page document. So let me know if you think I'm going too slowly, or you're finding these too easy or too hard. Now we'll look at setting fonts. So all of these have been probably going in Helvetica, which would be a default font for PDFs. When you do PDFs, there are some standard fonts. There's 14 standard fonts that Adobe has said that will be available in your PDF. So you can use any of those 14 fonts, and they'll be able to be rendered at the end user. So we'll create this document, PDF Demo 9, to use some of those standard fonts. In fact, it'll use all of the standard fonts, and we can get to see what they look like, and then we can try using some of the fonts ourselves in the task. So we'll run PDF demo 9. And here we go, we've got the 14 standard fonts, and you can see there's a font for Courier. There's a bold version of it. There's a bold italic version that's called Courier Bold Oblique. There's just an italic version. So we've got Courier, which is a monospace font, if you need monospaced. Helvetica, which is a sans serif font. Times, which is a serif font. And then you've got Symbol and Zapftingbats, which you probably don't need to use these days, and they didn't even render, well, they can't render letters, and they're just using for symbols. But with the Unicode these days, it's better to use Unicode symbols if you can. Although, if you want to use any fonts other than the 14 standard fonts, you need to embed them in the PDF. So I will show you how to embed them later. All right, so let's use a couple of those fonts in some code. I'll move this off to the side, and we'll do a task which uses a couple of fonts. So you should be getting pretty good at this by now. Set up the canvas, set the font. Now to set the font, which we'll set it to be Times Bold Italic. So you can get the name off the PDF that we just created in the demo, but you have to spell it correctly. Then we want to give it the font size, so let's make it a bit bigger, let's say 15 point. And if we look at the help on set font, it wants the font name, the size, and leading. So we'll just leave leading blank for now because we can't even, the drawstring doesn't even do new lines, so there's not much point in specifying leading. Leading is the space between lines. It's called leading because in the old typesetting days, they used to use lead between each row of characters to space them out. So the amount of lead you needed was how much space you needed between lines, and so that was your leading. We'll draw our string. And we'll call it quick. What's it say? We'll do it at, I like doing it up near the top, so 30 millimeters to 50 millimeters quick. And what we can do is compare the italic version and the non-italic version. String, and we'll make this a bit lower, so still 30 millimeters. And to 30 millimeters. Quick. Regular. And quick. Italic. And remember to save this. And then we call it. Need to create that one anymore. And now I run this, Control Shift R or Control Shift F10, and let's have a look at what it came up with. So you can see the italic version is not just the regular version with a slope on it. That little tail on the Q looks quite different on the italic to the regular, and that's why they've had to create a whole new font just for the italic version compared to the regular version. So I'd be interested to hear if you're getting any success in running these exercises. So try, let me know how you're going. If there's anything that you've got any questions about how to do something with a PDF, let me know. Right, so we've seen drawstring. We saw the problems with it. We have to provide an X and Y coordinate every time we want to use it. But ReportLab has got a thing called a text object, which does keep track of its X and Y coordinates as it's moving along. So we'll show an example of how to use that. I find it a little bit better than drawstring, but in practice I haven't used it much because I use drawstring when there's times when I just need to put a bit of text in a particular place, and then when I want to do longer things, then I go on to using the Platypus way of doing it. So we'll go on to that next. But for now, we'll look at the different things you can do with text. You get your text object from c.beginText. You set the origin, so you give it X and Y coordinates where you want to start. You can even set it with a font and a size and leading. Now leading will make a difference because it can do new lines and continue on from that. Now you can do text out, which just means it'll put that text out and it'll leave the current text positions like a cursor at the end of that line of text. And then if you do more text, it will keep going after that. And then if you do a text line, which is this one down here, it will continue on from where it was, and then at the end of it, it will drop a line. So text line means it'll drop to the line at the end of the line. You can also do text lines if you've got lots of lines with carriage returns in them. So new lines, these new lines here, they will all be respected, and draw text will drop a line for each new line character. So let's have a look at this one, PDF Demo 10. There we go, this is text out, text out, text out. This is a text line, but it's the end of the text out. So at the end of this one, it drops to a new line. We've got a very long line, that can still run off the page, so it doesn't help us much there. We've got a paragraph with sentences and new line characters. Once again, that runs off the page, it doesn't drop down because we've just used the text line command. And then here we've used the text lines command, and so it drops down. It's got a leading of 24, so it's almost double spaced. All drops down, all very good. I've put 2 pages on this document, but they don't go on to the next page. They just go off the end of the first page, and the second page is empty. So as you can see, it's a little bit better, but it's not great. I don't think we'll bother doing the exercise of writing our own, because I think that demo really demonstrated everything. And we'll go on to using Platypus. So when you're specifying stuff to put in a PDF document, there's so many different things that you specify. You've got to specify positions, you specify colors, you specify thicknesses of lines, specifying fonts. And if you have to do all these specifications using code, you get quite long programs that are quite difficult to read and very difficult to debug. So what they've come up with is this concept of flowable text. So, and they've called it Platypus. Platypus has got a good name. I can't remember what it is now, but it's an acronym for something. And you can read all about it in section 5, 6, up to 9, all these sections in the manual. And so this is what I would recommend if you're needing to do PDFs, because it does a lot of the work behind the scenes, and you don't have to keep specifying things over and over again. And the way it works is by having these concepts of flowables. Something that's flowable is that you just place it on the page and it flows down the page in a frame and when it gets to the end of the page, it will then flow on to the next page. So Platypus does the work of working out where the page end has happened, works out when the sides of the page have reached, and so it can auto-wrap text. So this is what I would recommend as the way to go. So let's look at an example. Once again, I've done a very complicated example, and we'll see if we can, to do the task, which was use Platypus to take flowable text more than one page long. Okay, so I've created a method here for numbering the page. That's fairly advanced, so you can look at it if you want, but it's not really required. And here's my demo. I create a simple doc template, and this is what a template they provide. They show you how to create new classes of doc templates, but even their simple one will actually do most of what you ever need to do. So I've never needed to create my own doc template. I just keep using theirs. They've got style sheets, so they're starting to use the HTML model a bit of how to specify things, because HTML has turned out to be quite a succinct way of providing all that information that you need for a web page to be laid out, while still separating style from content. So the style sheet is the style, and the content is obviously the text or whatever we have going into the flowable. So what we do is we create, there's the style. There's lots of things you can edit in the style. I wonder if I should show you some of them. So if I go into here, let's import sample style sheet and have a look at all the different things that can be edited in a style. All right, so let's see, sample style sheet equals get sample style sheet. All right, that's sample style sheet. And it's got different style sheets in here, and you can see by name. Here's a few of them: normal, body, italic. So they're the different ones that they've provided for you, and so you can grab one of those, and then you can make changes to it, or you can create a new one if you want. So let's we'll get one. Have a look at heading 1 equals sample style sheet. Heading 1. Okay. So if we look at heading 1, it's a paragraph style, and here's all the different things. You can set alignment, whether it allows orphans, widows, back color, border color, bullet, anchor, font name, embedded hyphenation, end dots, first line indent, font name, font size. So there's a lot of formatting information just stored into this style. And if you had to set that all programmatically, it'll take you a lot of code to do it. So it's quite convenient that they provided a lot of those, and we just have to change the ones that we want to change. So what we've done here, we've grabbed the paragraph style called body text. We want to change the alignment on it. We want to change it to justify rather than left aligned. And so I grabbed the TA justify from reportlab.lib.enums. The space before, I've set it up to 18, and I've grabbed another style called heading style, which is just based on heading 2. All right, now we're going to construct our story, which is really just a list. It's a Python list, and we just plonk all our things into that list, and they will get rendered on the PDF in the order that they are in that list. So the first thing we'll do, we'll stick in a heading saying paragraphs of text, and we'll create some paragraphs. So paragraph is one of these flowable things. We've got paragraph, list, item list, flowable, pre-formatted. These are all flowable items. And so we'll use paragraph. And paragraph is probably the most common one you will use. So we take some text. We've used that for a heading there, using the heading style. Then we'll do another paragraph with the paragraph style. And this one will use this text here And we want to do some inline formatting. So it will actually accept HTML tags, a few of them. Look up the manual to see which ones they do accept. They'll accept some that aren't even HTML tags, and they'll accept some of the HTML ones. So we'll say this is, so it's strong, so it'll be like a bold format. And then we've emphasized with an EM tag the word paragraph, so that'll make it like italic. We're using a format string, so we just want to put a number in there. So it's going, this is paragraph 0 with 10 sentences formatted using. Now I do want to do less than and greater than signs, but I can't use them anymore because they are used for tags. So I have to escape them the same way you'd escape them in HTML. So ampersand LT semicolon is the same as a less than sign. Ampersand GT semicolon is the same as a greater than sign. All right, so that's created paragraphs. So that's a good start. I think we should run this and see what that looks like. And then we'll go back to the code and see what else it's doing. So I'll run this to create PDF demo 11. And here we go, paragraphs of text. This is, you see, this is bolded. I can zoom in on that a bit. This is paragraph, so paragraphs in italics with 10 sentences formatted using, and then that's where I did want to use greater than and less than signs. So I've used the ampersand LT and ampersand GT escapes to show the actual tags. And I've just repeated the same text over and over. Paragraph 0, paragraph 1, paragraph 2, paragraph 3. And then that page numbering is something that will happen automatically when it gets built. So I'll show you that later. That's a more advanced topic. And we've got our 10 paragraphs. And then we've got a page break. And we'll look through the examples of the styles. So I've gone through every style in the sample style sheet and I've drawn it out using that style. So normal is a paragraph style. Body text is also a paragraph style. I think it's got different spacing before and after to normal. Italic, if you want a whole paragraph in italics, then you see heading 1 is quite large. It's got a title, which is a centered style. Heading 2, heading 3, heading 4. I've got bullets. Definitions, codes is a monospaced font style. And then we've got these ones, unordered list and ordered list. Now these are list styles, so you can't use them in a paragraph, but you can use them in list items. So they've actually been drawn not in their style, they've been drawn in the normal paragraph style. Okay. Let's see how I did that. So I did a loop here for the examples of styles, for the style name and the style in style sheet by name items, which is just a dictionary of them all. And I created the style description, which is just its name, as you saw, and the type of it, telling me whether it's a paragraph style or a list style. And then I used duck typing to try out the sample style. So I just used the style on itself. If that didn't work, it gave me an attribute error. List style doesn't have font name attribute, so it can't be used with a paragraph. In which case, I didn't use style, which comes from here, as it iterates through all the styles in the style sheet. I used parastyle, which we set right at the beginning to use for anything that we didn't have a style for. So I created that story. It appended one paragraph for each style into this story list, so that story list is just growing longer and longer. Then you can see some other things I've done: story.append, paragraph, built-in functions, and classes listed in 2 columns. So I've grabbed all the built-ins in Python, and I've put them into a list. And so for the list item, I've used normal style, and then for the list style itself, it's going to be have Courier for the bullet font name and font size 10 and left indent. And then, rather than put that list directly onto the page, I've put it into another flowable which is called balanced columns. And from balanced columns, I can put in F as my flowable, which is my list. And I say I want it done in 2 balanced columns. And then so I've appended that. I've then put in a page break, and then I've continued on for the next bit. So the next bit, I'll show you how to do formatting text using white space, and that's where you use the pre-formatted rather than a paragraph. And so I've just used this ASCII art here, which relies on white space to actually make it look like anything, and that gets sent out. So remember before we were using less than and greater than signs for tags in paragraph. For pre-formatted, I don't need to do that. I can actually just put in less than and greater than signs, and they'll print out as less than and greater than signs, because you can't put any inline formatting into pre-formatted. You can only do it in paragraph. All right, and I've used the code, which is a monospace font for that, to make it space properly. And then when I build it, so doc.build, that's that simple doc template. I run this build command. It takes the story, which is, remember, just a list of flowable items. And I also say on the first page, I want to do a numbering of the page. So that's the function name that I had before. And on later pages, also do a numbering of the page. So if I run that, I've done the less than and greater than now. So let's see if that showed in Beginner's Python. So here's our balanced columns and our list. So that's in Courier, but these paragraphs are just in our normal Helvetica. There's our page number. So you can see it went down 24 to 48. So it's worked out that it can do 24 lines before it got to the end of the page. So it's done 1 to 24 in the first column and 25 to 48 in the second. And then it started from 49 to here, and it's kept going. So it's quite a clever thing to do. That's the next page, and that's the end of the 152. All right, formatting text using white space, and you can see I've put a less than and greater than sign in there, and that's now showing properly. Okay, I'm not hearing much from you guys, so I presume you're just racing along with this stuff. So let's do a demo. Let's do a task. Use Platypus to take flowable text more than 1 page long. All right. So let's try. What do we need? Okay, that's a shame, Annie. You didn't get ReportLab working, but. I'm just sorry I can't help you with Spider. Did you get the email working last week? Oh, okay. The same issue. So didn't Spider get installed with Anaconda? Okay. I'll have to have a look at that. All right, so let's create some paragraphs. So why don't we do the? I know we'll do like the built-ins, the list of built-ins. So we iterated through them before, and this time, where do we do that? We did that in the. Here. So let's do a paragraph for each built-in, and it's just going to be a paragraph B plus I can just use all of this. This is looking good, and if I can do a couple of line feeds plus inspect dot get documentation for the built-in. I've got to import inspect. We'll use a style sheet. I already had one, I'll call it parastyle. Okay. For B in directory built-ins. Paragraph. So, well, I mean, I can just, that can be just our story. Let's call it story. And then we just build that. So I think we'll find that these new line characters won't work, but we'll give it a go. Let's run this, PDF task 11. And we can not, yes, that's right. So some of these don't have documentation. So we've got to do a proper, we can't use list comprehension. We could, but it would get a bit complicated. So let's just do it this way. For B in built-ins, doco equals that. So what I'm doing here is I'm using the expect module to get the documentation for each of these commands. So for example, if I imported inspect here and I wanted to have the look at the documentation on the round command, it tells me here round a number to a given precision in decimal digits, the return value is an integer if n digits is omitted. So, but sometimes the doco could be none, so we just have to put a test in for that. We'll append the paragraph. and build the story. So I'll see how we go with that. Module object is not iterable. Oh, yep. Want the directory of the built-ins. Okay, task 11. So yes, arithmetic error, base class for arithmetic errors. Assertion error, assertion failed. So that's just gone through all of the built-in functions and printed the documentation along with it. Now if we want to maybe format that a little bit, we can maybe make it do some inline formatting. So I could use format strings for this as well. In fact, I should use format strings. And then do some line breaks. I like doing these. And then do the documentation. Okay, so that's, we changed it. So I've got a couple of line breaks and then the rest of the paragraph. All right. So any questions on that? No, not getting any questions. So let's come up with create a table in PDF that spans more than one page using Platypus print page X of Y at the top right of each page. Okay, so this bit here, print page X of Y at the top right of each page, is a really difficult problem, and so that's really an advanced subject. So I'll go through these things. Okay, so we're going to create a table. So our demonstration is to do an invoice. So the invoice is going to be several pages long. So we're going to have several columns. We have the items, quantities, and amounts, and we're going to have a total at the end. But we want it, because the table spans multiple pages, we want to repeat the headings of the tables on each of the pages. And on the first page, we want to put a lot more letterhead type stuff, but on the following pages we can fill it up mostly with the table. Now, to make things a little bit more difficult, our table is going to have lots of Unicode characters in it. So we're going to show the problem first of using just the standard font Helvetica, and then we're going to see if we can get around that problem. So I've got a function here, register language fonts. We'll ignore that for now, and we won't use it. And so I've just got that disabled, so we won't register them yet. Numbered canvas. Now this is some code I've just taken from somewhere else. I think I modified it slightly. Here's the URL I got it from, and it shows you a way of printing the page X of Y. So printing page X is really easy because you just know at any time what page number you're on, and so you just say I'm on page 3 and print that. But you don't know how many total pages there are till you finish the whole document. So this is a fairly clever way of overriding the canvas class, giving it a new, so creating a new class called numbered canvas, and by overriding it, we don't get it to create the page number until it's been through the whole document, and then it does all the page numbers at once. So you can see what it does here. When you say save, it doesn't it saves it, but it grabs the number of pages at that point and stores it in a local instance variable, and then so it doesn't actually do the real save. So when they call show page, which is when they're starting a new page, and that's what the Platypus flowables do as well, it doesn't call the superclass show page at that point. What it does is it saves the page for later, and then when they do the save right at the end, that's when it calls. It knows how many pages there are total, because it knows how many times it's saved a page state, and then it puts in the number of pages at that point, and then calls the show page itself, and then saves the whole lot. So it's a fairly tricky thing that it's done. I wouldn't expect you to understand it, but that's a useful routine that you can just copy and paste, and you've got a class there that you can use for creating numbered pages where you need to know the total number of pages. Okay, now on the first page we want to do a header that's got our company logo, in a big company logo. It's going to have the word invoice, and it's going to have today's date on it. On the later pages, we're just going to have a small version of the company logo, which is just 3 rectangles. We don't need to have the word invoice or the date, but we do want the page 2 of 3 and page 3 of 3 to show. Paragraph description. So what I'm trying to do here is create a paragraph that describes a Unicode character. So this is not really ReportLab. This is me playing with fonts. I guess it is a bit in ReportLab because I have to choose a font based on the Unicode name of the font. So we'll see. It'll start off by looking for all the fonts we've got registered, and if it doesn't find any as a default font, it will use Helvetica. Here's the data we're going to put in the table. I've kept that out just in a single function. And so it's the headings: item, quantity, part, description, unit, price, and price. And then it'll just go through all these Unicode characters, look for any that are numbered, a number type, because Unicode have a category, and it's going to include them. So it's really interesting. We're using the Unicode values of these Unicode numbers in our prices, so you can see some of the different things that are in there in Unicode. And this is actually the PDF demo 12. We create the doc template. We set the top margin to 30 millimeters. And then on the first page, we put in a spacer because we want to leave enough room for the first page letterhead to show. And then we start with our table. We've got the widths here. We want to repeat the top row. And I've put a few formatting things in here. I don't think I'll go through all the formatting at this stage. They're in the manual if you want to read them. If you've got any questions about specific formatting, then ask me, and I can go through it then. All right, so we append the table to the story. We build it. Remember, on our first page, we're using this function, invoice header first, to create a letterhead. On later pages, we just want invoice header later. And our canvas maker, this is where we say we don't want to use the normal canvas, we want to use numbered canvas, and we just put the class name in here. So let's see how that runs. So you can see here, this is the stuff that we're creating, these paragraph descriptions. I've just sent some logging messages so I can see what's going on. It's doing things like 1/7 and the Unicode name for that is vulgar fraction 1/7. It's an NO Unicode code type, which is number other, and that's its value, 0.142857. That's a number actually stored in the Unicode data library. We've also got these Ethiopic numbers. The Ethiopic number 40 looks like this. So I'm quite impressed with my operating system is displaying these, because most fonts do not have a glyph for the Ethiopic number 40. And I don't know how Mac is displaying that font, but it's somehow, because I couldn't find any of the fonts currently installed on the system that have that value in there. But anyway, Mac's doing it, so there must be a failover font somewhere that is got all of those in it. All right, so let's have a look at what the PDF came out looking like. Here we go. So our first page, it's saying page 1 of 3, and you can see there are 3 pages. We've got a big company logo on the first page, the word invoice and today's date, and then our table. So our table, our item, that's just a number that's increasing one by one. Quantity, I've taken that as the last digit on the decimal Unicode value for the character. This is how you can use the Unicode character if you actually want to use this one in your Python strings. You just use \U1369, which is the hexadecimal value. And there's its description, Ethiopic digit 1. We'll give it a price of $1 because that's what the value of that digit is. So that's $2, $3. And so the quantity 9 times the unit price gives us an extended price of $9. And you can see here it goes up to 100, 10,000. There's the number for 10,000, but none of them are showing in Helvetica. So that's pretty disappointing, as we can't get any of these Unicode characters to show. But you can see the coloured lines I've got on the top of the headings. We've got the repeated rows for headings and the total line at the bottom. So let me know if you've got any questions on any of that. So what we're going to do, the built-in Helvetica font doesn't have all these Unicode values, but we can, Arial's got quite a few in there, so we can register Arial as a font, and then it will embed the Arial font in the file. If I look at the file at the moment, reveal in Finder, I can see that it's 7K. So let's have a look if I embed some font, embed a font, whether that changes it. Okay, so I'm going to run this function here, register language fonts, one that I've written, and it's going to register Arial as a backup embedded font. So it's going to put Arial in there as a font, and it's going to set that as the default. So I'm not going to do any others. So languages, let's hide this. So languages is just a dictionary. So the default font is unnamed. Ethiopic is the word Ethiopic, Kama, Utailu. And the reason I've got these names in here is because this name here, Utailu, is what comes out of Unicode data, and this name here is what we'll use to identify a font from Google later on when we do that. But at the moment, we're just going to work with default. So we're going to try to register these other fonts, which are these Google fonts, but they don't exist. So that's just going to accept, and the variation, we're just going to go regular. We're just going to say our family is just going to be Arial for that font name. So if anyone tries to use that font name, it'll just come back with Arial. So I've just used, it's like duck typing there. Okay, let's register Arial and run this. So now when I run it, I've gone from black boxes to white boxes, but you'll see later on, some of them have got a code, like 1/3, 2/3, the 1/8. So I've got the 1/8 and the 1/3. So not much better, but it's an improvement. So let's go and embed some more fonts. And it took me a while to find some good fonts, but Google have got this project called No-To, which means no tofu. And they call those squares that we get when the font doesn't have that glyph, they call that tofu. So their plan is to not have tofu. And so they've got all these fonts here. Now, they haven't put them all into the one file because they figure, well, no one's going to want to have really more than one. But if you put all the files together, it's 1.1 gigabytes. So we obviously, that's just for a single font. I mean, it's got two versions. It's got a serif version and a sans serif version. But yeah, if you wanted to display a serif and sans serif for all the Unicode characters, you're looking at 1.1 gigabytes of font for just a single font. So you can download the ones there that you want, or just a couple of the ones to try it out. If you're on Mac, I've written a little script here that'll do that. That should work on Linux as well, but I couldn't think of one way to do it on Windows. So that just makes the directory change called fonts into our project directory, uses curl, which is like wget, to download them all, and then unzips them. So let's go and run that. So it's made the directory, changed into the directory, it's downloading the fonts. It's unzipped them all. And so if I look up here, I've now got a fonts directory with all these fonts in. So now if I run it, those fonts exist, and so it should be able to register them when I run it. And so let's have a look at PDF demo 12. And there we go, success. We've now got all our Unicode characters showing correctly because we've had to embed the Ethiopic language, the Runic language, the Khmer language, New Tai Lu. The superscripts are there, they're just in the standard Noto, and it's got all the fractions as well. So if I reveal in Finder, and we'll open that one with Adobe Acrobat Reader. Which I've obviously never opened in this username. So if I go to the properties of this file, it'll show me under fonts what's been embedded. So Courier, Helvetica, they're your standard ones, and then these other ones have been embedded, and it's just embedded a subset, so it's not hundreds of megabytes as would be required if the whole font was embedded, but it's just taken a subset for the characters that we need. And that's what they look like. So let's go back and have a look at the size of it. 33K, so that's not too bad, but it's a lot bigger than the 7K or so that it was before. Now, there's some fairly complicated things going on in that. I would recommend just playing around with it, disabling some things, try to do it yourself and see how I've done it. But you're not going to understand it if I just describe it line for line in the code. No, I think that's oh yeah. So for our last demonstration, because we've been using this format, every function we can pass in a file. We can also pass in a buffer. So we just show that will also work. Sending it through Gmail. So let's run that and just check that works. Gmail response, okay. Exit code 0, so Python says everything's good. Let's go look at our inbox. And it's not there yet. There it is. That's the one, and Google Chrome is displaying that correctly, all the fonts. So that's pretty impressive. Okay, are there any questions on that? While I'm waiting for questions, we'll just have a quick look of Spider selecting virtual environment. Hey. So I don't know if that's hooray for Spider or hooray that we're over the PDFs. So install. So this is the old way, pip install virtual env, creating for your project. So we know how to create a virtual environment. Activate, we know how to activate it. All right, Vincent's going to do it a couple of times. So what, he's going to watch the video a couple of times. That sounds like fun. So we're going to, that's been activated, perform actions in your environment. That's all in the command line. We know how to do that. Here we go, configure Spider for your environment. So I click on Tools, Preferences, Python Interpreter, use the following Python interpreter. And that's where you select the one that's in your scripts folder in your virtual environment. Yeah, so Vince, yeah, I recommend just try with the simple examples first and then try to get them to do a little bit more each time. You could possibly go straight to the Platypus stuff because the other stuff is, you're not going to need it that much, but it was quite simple to get through that first thing before we got to Platypus anyway. But try the different ways of things you can do with Platypus. So Annie, have you got this option in your Spider preferences? While you're looking at that, I'll check the Stack Overflow. Okay. PWD doesn't work. Is there a Python API for something like LibreOffice? Yeah, you can actually write Python scripts and you put them in a folder and you configure LibreOffice to use that folder, and that way you can write Python scripts that work inside LibreOffice. And there is an API. I haven't called it, but I'm sure it's possible. So that could be a good topic for a future session. So Annie's saying PWD doesn't work. Is that password, or is it PWD as in find the Python working directory? Can't see PWD on this. No, there's no PWD on this page. Okay, yeah, so you're looking at a, so Annie's got an Anaconda virtual environment called venv email PDF, and all the Anaconda virtual environments are stored in the same folder, in the one folder, which is a subfolder of your Anaconda installation. Unfortunately, I don't have Anaconda installed, so let's try Spider selecting Anaconda virtual environment. Okay, it's given the same one. So I've been using Spider installed with Anaconda. Okay. Open Anaconda Navigator, environments. So that's where you see all the environments that you've created. So you should see it in that list. Install Spider, which I'm sure you've done. Clicking on environments takes you to a management window for the modules installed on such an environment. Searching and selecting the Spider related ones. Okay, I don't know if that's what we want. Even this. Oh, okay, this is if the other stuff doesn't work. Okay, so launch and run. Click launch and run. So we could look at where does Anaconda install environments. All right, so you can actually specify where it goes. So that might be useful. Anyway, any other questions? You can keep asking me. After I've quit here, Annie, I'll fire up my Windows machine, and I've got Anaconda on that one, so I'll see if I can get the virtual environment linked to Spider on that one. If there's any more questions, I'll just sign off. So thank you all for attending, and next week will be a beginner session, and then the following 2 weeks after that will be the machine learning with Arun. All right, can you share the link? Okay, I've got a couple of links here. Yes, I couldn't read Vince's image either. Okay. Anyway, see you later.